In the farthest reaches of the observable universe, somewhere in the silent depths of a galaxy cluster called Phoenix, there lies a sleeping monster. For billions of years, it remained hidden, surrounded by the cold brilliance of ancient stars and veils of glowing gas. But then, something unimaginable happened. The monster woke up, and when it did, it unleashed a roar so powerful that it reshaped an entire region of space. Astronomers would later call it the most energetic outburst ever recorded in the universe. This is the story of Phoenix A. Imagine a cosmic explosion so massive that it carved out cavities in space larger than the entire Milky Way galaxy. A force so powerful, it ripped through clouds of superheated gas and left behind a scar that can still be seen across millions of light-years. Yet, unlike the violent chaos of a supernova, this explosion wasn't just a fleeting burst of light. It was the slow, unstoppable breath of a black hole feeding on the universe itself. You might be wondering, how can something that devours everything, that allows not even light to escape, explode? Isn't a black hole supposed to swallow, not erupt? That paradox is exactly what makes Phoenix A one of the most extraordinary discoveries in modern astronomy. The story begins with a cluster of galaxies over 5.8 billion light-years away, a region so vast it contains thousands of galaxies bound together by gravity. At its center lies a supermassive black hole, an object millions of times more massive than our Sun. To the human eye, it's invisible. To the universe, it's one of the most influential forces that exist. For a long time, the Phoenix cluster seemed like many others, bright, hot, and quietly humming with activity. But when astronomers began observing it using NASA's Chandra X-ray Observatory, they noticed something strange. The glowing gas around its core wasn't smooth or uniform. It had enormous voids, regions where X-rays simply disappeared. These weren't small gaps. They were cosmic craters, evidence of something vast and violent that had once pushed everything away. At first, scientists thought their instruments might be malfunctioning. How could anything carve out a cavity that large, hundreds of thousands of light-years wide? But further data confirmed the truth. These holes in space were real, and they had been blasted open by jets of energy from the supermassive black hole at the cluster's core. Now try to picture it. A black hole, surrounded by a swirling disk of gas, begins to feed. As matter falls inward, it doesn't vanish quietly. The intense gravity crushes atoms, generating magnetic fields that twist and coil until they launch powerful jets of plasma out from the black hole's poles. These jets, moving close to the speed of light, slam into the surrounding gas and push it outward. Over millions of years, this process can sculpt cavities, leaving behind a faint echo of the black hole's hunger. But in the case of Phoenix A, this wasn't a gentle exhale. It was a cosmic scream. The energy released was equivalent to hundreds of millions of supernovae exploding all at once. To grasp that scale, imagine every star in the Milky Way detonating together, and then multiply that by a few hundred. Even then, you'd barely approach the power of Phoenix A's eruption. It was an explosion so immense that it heated the cluster's gas to tens of millions of degrees, producing X-rays detectable across the universe. And yet, despite this unimaginable violence, everything happened in near silence. No sound, no light visible to our eyes, only the faint shimmer of X-rays revealing the scars long after the outburst faded. It's a strange thought. The universe's most powerful explosion, and no one could have heard it. For billions of years, the black hole remained calm after that colossal event, perhaps exhausted from its own fury. But in that single act, it had changed the destiny of the Phoenix cluster forever. The surrounding gas, once cool enough to form new stars, was heated beyond the point of collapse. Star formation nearly halted. Galaxies that might have birthed new suns were left in cosmic limbo, frozen by their central black hole's rage. But there's something even more mysterious. Astronomers still don't know why the black hole erupted with such extraordinary force. What triggered it? What made it so much more powerful than any outburst ever recorded before? Some believe that the black hole went through a period of rapid feeding, swallowing enormous amounts of gas from its surroundings before suddenly ejecting much of that energy outward. Others think it might be the result of an interaction with another galaxy, a collision that disturbed the delicate balance at the cluster's core. Whatever the cause, Phoenix A challenges our understanding of how black holes behave. It reminds us that these are not just dark, empty voids. They are living engines of the cosmos, sometimes silent, sometimes unimaginably loud. If you were somehow floating near the Phoenix cluster during this event, not that you could survive it, you wouldn't see a bright explosion like in the movies. Instead, you'd witness a slow, majestic unfolding. The hot plasma jets would expand outward in ghostly arcs, glowing faintly in X-rays. The surrounding gas would ripple like waves in a pond, spreading the energy for millions of years. It's an explosion that moves at the pace of time itself, a storm measured not in seconds, but in eons. As we watch the faint traces of this cosmic outburst from Earth, we're essentially looking into the past, seeing an event that happened long before our planet even formed. And yet, it still speaks to us, whispering through the cold silence of space, telling the story of creation, destruction, and rebirth on a scale beyond imagination. Because, in the end, that's what Phoenix A really is, a reminder that even in the universe's darkest places, energy and motion never truly die. They just change form. And in that transformation lies the rhythm of the cosmos, the eternal cycle of sleep and awakening, collapse and eruption, silence and light. When the Phoenix cluster was first catalogued, it didn't stand out. To telescopes scanning the universe, it appeared as yet another glowing knot in the endless web of galaxies. Astronomers saw a bright central region, some hot X-ray emission, and countless galaxies orbiting one another in slow, gravitational dance. But in 2019, something unexpected happened. When data from NASA's Chandra X-ray Observatory was combined with radio observations from the Murchison Wide Field Array in Australia, scientists noticed something strange, an enormous, symmetrical void in the X-ray map. It was as if a colossal hand had scooped out a section of glowing gas and thrown it into the dark. The first reaction from the research team was disbelief. These cavities were far too large, far too structured to be anything ordinary. To be sure, they checked for instrumental errors, for data mismatches, for any reason to explain the absence of X-rays that didn't involve the impossible. But the evidence held. What they were seeing was real. The black hole at the heart of the Phoenix cluster had once released a burst of power so immense that it had physically reshaped the cluster's core. In the cosmic stillness of that galaxy cluster, the outburst had traveled outward, sculpting two gigantic cavities, one on each side of the black hole, each one hundreds of thousands of light-years across. The amount of energy required to carve out those cavities was almost beyond calculation. To put it into human perspective, the energy released was about 5 times greater than the previous record holder, an eruption in the Ophiuchus cluster. That's equivalent to hundreds of millions of supernovae detonating simultaneously. But what makes this even more fascinating is how quietly it all happened. In space, there's no air to carry sound, so even though this was the most powerful explosion known, it occurred in utter silence. The only trace of its fury was written in X-rays and radio waves, whispers from an event so distant and so ancient that its light took billions of years to reach us. Astronomers often refer to black holes as sleeping giants. They spend most of their existence quietly, consuming small amounts of matter, sometimes not feeding at all. But occasionally, something changes. A galaxy drifts too close, or a cloud of gas collapses into the center. And when that happens, the black hole wakes up. It begins to feed. Matter falls toward it in a spiraling torrent, heating up until it emits X-rays and gamma rays. Magnetic fields twist, energy builds, and then, like a breath released after eons of silence, jets of plasma burst from the poles, cutting through space like cosmic spears. For Phoenix A, this awakening was on an entirely new scale. The black hole must have drawn in a staggering amount of material, perhaps the remnants of a nearby galaxy that wandered too close. As it fed, the pressure at its core built up until it could no longer contain it. Then, in one of the most violent displays of energy ever seen, it expelled vast streams of charged particles into the cluster's surrounding gas. Those jets moved at nearly the speed of light, pushing the hot plasma outward and creating 2 enormous bubbles in the cosmic medium. These bubbles, or cavities, became the signature evidence of the explosion. They were the fossilized remains of the black hole's fury, massive voids where energy had displaced matter. In the years that followed, astronomers used multiple telescopes to study them in different wavelengths. The Chandra X-ray Observatory revealed the hot gas. The XMM Newton satellite confirmed the energy distribution. And the giant meter-wave radio telescope in India showed faint traces of radio emission, echoes of the plasma jets that had once been unleashed. Together, these observations painted a breathtaking picture. The black hole had released more energy than any known cosmic event outside the Big Bang itself. It was quite literally the loudest explosion in the universe's history. Now, imagine this event unfolding across millions of years. To us, it sounds instantaneous, one massive eruption. But in cosmic time, this was a slow and steady storm. The black hole's jets didn't explode in a single moment. They roared for ages, gradually pushing against the cluster's hot gas. If you could watch it sped up, you'd see the cavities expanding like bubbles in boiling water, growing and stretching until they reached their colossal size. What makes Phoenix A's story so mesmerizing isn't just its power, it's its elegance. This was destruction with purpose. The outburst didn't simply tear space apart. It also prevented the galaxy cluster from collapsing under its own cooling gas. Without it, the Phoenix cluster might have given birth to countless new stars, consuming its reserves of gas and growing unstable. Instead, the black hole's eruption reheated the cluster, keeping it in balance. It's a strange irony. The same black hole that destroyed its surroundings also saved the cluster from imploding. In that sense, Phoenix A became both the destroyer and the preserver, a cosmic paradox that mirrors life itself. Chaos creating order, destruction bringing equilibrium. Mini Hook. The more astronomers studied Phoenix A, the more they realized they were staring at something that defied their expectations of black holes entirely. This wasn't just an explosion. It was a message, a clue to how the universe regulates itself. Because black holes, as terrifying as they seem, are not simply consumers. They're cosmic regulators. They determine how galaxies evolve, how stars are born, and how long clusters like Phoenix can survive. And through this single, ancient outburst, Phoenix A revealed that the universe is not a chaotic void. It's a system governed by cycles of balance and release. When scientists calculated the energy output, their results were almost surreal. The total energy released was equivalent to 10 to the power of 45 joules. That's a number with 45 zeros after it. It's so vast that no human analogy can truly convey it. If you took every single nuclear bomb ever detonated on Earth, multiplied their energy 1 trillion times, and then multiplied that by another trillion, you'd still fall short. Yet, even this monumental force was not infinite. Eventually, the jets faded, the black hole grew quiet again, and the cavities it left behind began to cool. Over time, gravity and temperature would work to refill them, but their scars remain, timeless reminders of the most powerful roar the cosmos has ever known. And as the Phoenix cluster now drifts silently in space, billions of light-years away, its name feels eerily fitting. Like the mythical bird that rises from its own ashes, this cluster was both consumed and reborn by fire. In the months following the discovery, scientists around the world began to re-examine their data. They'd seen black hole outbursts before, many of them impressive, some even fierce, but nothing that approached the raw, majestic scale of Phoenix A. It forced astronomers to ask a simple, unsettling question. Have we underestimated the power of black holes all along? For decades, the cosmic narrative had painted black holes as silent predators, cosmic vacuums that consumed everything in reach and gave nothing back. But this event shattered that image completely. Phoenix A wasn't just absorbing, it was releasing. It was giving energy back to the universe in quantities that dwarfed the output of entire galaxies. This changed everything we thought we knew about how galaxies live, grow, and die. At its core, this discovery revealed a truth that was hiding in plain sight. Black holes don't merely destroy, they create balance. Their outbursts, though catastrophic, prevent galaxies from collapsing under their own cooling gas. When a galaxy cluster cools too much, its gas condenses and ignites a wave of star formation. Without restraint, that process could spiral out of control, creating a burst of young, massive stars that would eventually burn out, leaving behind chaos. But the energy from a central black hole acts like a cosmic thermostat, reheating the gas and slowing the birth of new stars. Phoenix A was the ultimate example of this galactic feedback system. Its eruption was so powerful that it single-handedly altered the environment of its cluster. For astronomers, it was like watching the universe's natural defense mechanism at work, chaos creating calm. When the research team at NASA released their findings, they described the cavities in Phoenix A as the largest explosion since the Big Bang. The phrase wasn't an exaggeration. The amount of energy released was so staggering that even after billions of years, the ripples from that event can still be seen. Imagine throwing a pebble into a pond, except the pond is a galaxy cluster, and the pebble is a black hole that just exhaled the energy of 100 million suns. The waves from that single act travel outward for eternity. What's truly fascinating is that these waves are not merely physical, they carry information. By studying the shape, temperature, and distribution of gas in the cluster, astronomers can piece together a timeline of events. Every cavity, every ripple, tells a story about how the black hole evolved over time. In that sense, Phoenix A is like a fossil record, not of bones but of energy. To understand just how scientists decode these messages, we need to imagine the instruments they use. Telescopes like Chandra, XMM Newton, and Loeffler can't see black holes directly. Instead, they study the afterglow of surrounding matter, the X-rays emitted by hot gas, the radio waves from ancient jets. When those observations are combined, they form a kind of three-dimensional map. And hidden within that map are the fingerprints of events that shaped entire galaxies. In the case of Phoenix A, those fingerprints showed something astonishing. The cavities weren't random. They were beautifully symmetrical, extending on both sides of the black hole like wings. That symmetry hinted at a controlled, sustained release of energy, a sign that the black hole wasn't simply erupting out of chaos, but operating under some mysterious form of cosmic order. Mini-hook, the deeper astronomers looked into the heart of Phoenix A, the more they realized the universe itself seemed to be alive, breathing in cycles of creation and destruction, as if following an ancient rhythm written into the fabric of time. Some scientists began calling this phenomenon AGN feedback, short for active galactic nucleus feedback. In simpler terms, it's the process by which a black hole regulates the growth of its host galaxy. It's almost poetic. The most destructive objects in existence are also the guardians of balance. Too little activity, and galaxies become overcrowded with newborn stars, collapsing under their own brightness. Too much activity, and star formation ceases altogether, leaving galaxies dark and barren. The perfect balance lies somewhere in between, and black holes, somehow, seem to find it. The Phoenix cluster demonstrated this balance in dramatic fashion. Before the eruption, its gas had cooled enough to spark intense star formation, so much that it was creating new stars at an astonishing rate. But when the black hole released its titanic burst, it reheated that gas, halting the process almost instantly. The timing was so precise that some astronomers described it as self-regulating, as if the universe itself had adjusted its own settings to maintain harmony. And yet, this realization carries a quiet weight. Because if black holes can control the fate of galaxies, then they are not just celestial curiosities, they are architects of the cosmos. They shape where stars are born, how galaxies evolve, and even how clusters of galaxies arrange themselves across the universe. Phoenix A is not just an explosion frozen in time, it's a demonstration of cosmic governance, of invisible order within the infinite. For those who study the night sky, there's a haunting beauty in that idea. The universe, vast and indifferent, still obeys subtle rules that preserve its structure. Every collapse gives birth to something new. Every act of destruction feeds creation somewhere else. And within that endless balance lies something almost conscious. When you gaze at the Phoenix cluster through the eyes of our telescopes, what you're seeing is not just a remnant of violence. It's a heartbeat, a pulse of energy frozen in light years, echoing through the void. Somewhere in those shadows, the black hole that once roared is now silent again, waiting for the next whisper of gas, the next drift of matter that will awaken it once more. Perhaps, billions of years from now, it will roar again. And when it does, another civilization, far away, may look up at its light and wonder, as we do now, what kind of force could awaken the very fabric of the cosmos itself. Because that's the essence of Phoenix A. It's not merely a story of destruction. It's a meditation on balance, energy, and the mysterious intelligence of nature. It reminds us that even in the cold silence of space, there's motion, rhythm, and intention. And as we watch it from our tiny planet, drifting around an ordinary star, we realize something humbling. That the same laws governing that distant black hole also shape the atoms in our bodies. We are, in every sense, connected to its fire. If you close your eyes for a moment and imagine the Phoenix cluster, billions of light years away, what do you see? A silent ballet of galaxies, slowly swirling around a hidden center, a place where darkness reigns, yet where light itself is born. Somewhere inside that void, a black hole rests, quiet, calm, as if meditating after an eternity of chaos. The violence that once shook its world has faded into memory, leaving behind a sculpture of stillness. It's easy to think of the universe as distant, detached, existing in some unreachable realm. But when we look at Phoenix A, we're not just observing something out there, we're looking at a reflection of ourselves. Because just like that black hole, we too go through cycles of collapse and awakening. We too destroy parts of ourselves so that something new can emerge. That's what makes this story so strangely human. A cosmic monster that once tore through space, now resting in equilibrium. A mirror of our own nature. We burn, we cool, we rise again. The same physics that drives the birth and death of galaxies governs the neurons firing in your brain at this very moment. The same delicate balance that keeps a galaxy alive also keeps you alive. Phoenix A reminds us that destruction isn't always an ending. Sometimes it's a necessary transformation. When the black hole erupted, it seemed like the cluster's doom, but it was also its salvation. It stopped the runaway birth of stars, restoring harmony to a system on the edge of chaos. It's a strange comfort to know that even in the deepest voids of space, balance finds its way. Many hook perhaps the universe doesn't seek perfection. It seeks rhythm, a quiet pattern of rise and fall, expansion and rest, much like the slow beating of a cosmic heart. Over time, astronomers realized that Phoenix A was more than just a discovery. It was a revelation. It showed that black holes, the supposed destroyers of worlds, are also creators of stability. They don't just take, they give back. They breathe energy into galaxies, regulate their growth, and sustain the dance of stars across time. Without them, the cosmos would descend into disorder. And that, in a way, makes them the unsung heroes of the universe, the keepers of balance, the silent guardians that shape everything we see. If you could stand on a galaxy within the Phoenix cluster and look toward its glowing center, you wouldn't see chaos, you'd see beauty. A faint X-ray glow spreading through the void like the ember of a dying fire. A reminder of a time when the universe itself roared. But from here, from our quiet blue planet drifting in the outskirts of a spiral galaxy, all we can do is listen. Not with our ears, but with our curiosity, with the instruments we've built to translate light into meaning. Every photon that reaches us carries a story, and Phoenix A's story is one of transformation. It's a whisper from the ancient universe telling us, even the darkest things have purpose. When you lie down at night looking up at the stars, or maybe listening to this story as you drift to sleep, remember that everything around you, everything within you, is part of the same great cycle. From the atoms in your skin to the galaxies beyond our reach, it's all connected through gravity, energy, and time. You are, in every sense, made of the same universe that birthed Phoenix A. So the next time you feel lost or small beneath the night sky, think of that black hole. Think of the moment it awoke, of the power it released, and the harmony it restored. Because maybe, deep down, the universe isn't random at all. Maybe it's teaching us something, that creation often begins with collapse, and silence often follows after the storm. And that's what makes the story of Phoenix a more than science. It makes it a meditation, a lesson wrapped in starlight. So, As you breathe out slowly and let your thoughts drift across the galaxies, remember, the universe is alive, pulsing, dreaming, and you are a part of that dream. Call to action, gentle, in character close. If you've enjoyed this journey through the heart of the cosmos, where even silence has a story, consider joining us for more. Subscribe to the Sleepy Minds and let your nights be filled with wonder, where science meets serenity, and every story of the universe helps you drift a little deeper into sleep. Let your mind wander through the stars, because somewhere out there, another mystery is waiting to be found.